this day, today, on the eve of this National Science Day, we have organized a very special session on teachers training program on the theme of properties of light. And I hope that we are all aware and excited about that today to conduct this session, we have a luminary personality with us, Professor H.C. Verma. And we are, I'm sure that we all feel fortunate to have been here today. We are teaching, the teachers that have come are all science teachers, and we have taken a lot of learning from the books that Sir has written. So we are very, very glad to have you, sir. The words cannot suffice the happiness that we have right now to see you on this very, very fitting occasion, the day when tomorrow on this Feb of 28th, when we all know that it was Sir C.V. Raman had announced the discovery of this Raman effect. And today we are here to get much more, understanding, of this light, where Sir will put a lot more light on these concepts for us to learn. So while we are going to begin this session, I just was thinking, what more should we say? Anyhow, this is just a basic introduction. I was just thinking that, for any successful person, or each one of us as well, that we are here sitting today, what motivated us to do science or anything that really, is close to our heart? We remember there was either a teacher, something the teacher would have really instilled some lot of interest into us, or an encounter to a personality, somebody spoke. It became a turning point for all of us. And we are so glad that today when Sir Verma sir is there with us, Sir has already instilled such sort of moments among countless of the Indian students, especially the youngsters. And each one of us also have got a flavor of it. So that makes the connections to happen. And today is one more day that we are here to learn, to get excited, to get intrigued by all the thoughts that Sir will present through his talk. So I welcome Sir, and I welcome all of you to begin with. But for so I also request in the meantime, I request our director, Shree Saju Bhaskaran, to come on the stage and set the tone of this event. Thank you.
Good morning and welcome to the museum. Today is a day which all of us were waiting for since many days. Actually, Jyoti was behind Professor Verma for almost more than 2-3 years, I think. And today is the date we could have him here. Welcome to you, sir. One pleasant welcome to you. Anyway, Professor Verma doesn't require any introduction, but I'll give a formal introduction to Professor Verma here. Professor Harish Chandra Verma is one of the most distinguished authors of physics in India, often referred to as an idol and pedagogical guru for all JEE aspirants. He has written several influential books on physics and is best known for his 2 volumes of books, Concepts of Physics. The book is considered as the Bible of physics as a prerequisite for students preparing for IIT and other engineering entrance exams. Currently, he is an emeritus professor in the Department of Physics at IIT Kanpur. Besides being a prominent author and researcher, he has co-founded many social initiatives like Shiksha Sopan, which literally means a ladder to education, for the growth and upliftment of underprivileged kids in and around IIT campus. Sir received BSc Honours degree in Physics in 1975 from Padma Science College and MSc in Physics from IIT Kanpur. Following it, he joined for PhD program at the Institute, IIT, and completed it in less than 3 years. Despite being motivated by his teachers to move to Europe and US for higher studies, he chose to return back to his native place and join Patna College as a lecturer in 1980. The college holds a special place in his heart since it transformed him from an average student who used to struggle with marks during school days into a topper. He dedicated 8 years of his life to complete the book of Concept of Physics, which eventually made him a luminary among Indian students. The book has not only shaped the preparation of generation of students, especially those attempting demanding examinations, but it has shaped how they think. After serving Patna Science College for 15 years, he joined the Department of Physics at IIT Kanpur as an assistant professor in 1994. Being a true experimentalist and researcher, he did not get convinced by the idea of starting a coaching center and decided to pursue research. His core research interests include classical and quantum mechanics and nuclear physics. He has authored another book titled Quantum of Physics. He has also made several video lectures on various topics of physics to help Hindi stream students also. He is hugely popular among his students and has advised and mentored several MSc and PhD students. He is a fellow of National Academy of Sciences and recipient of Padma Shree by Government of India in 2021. So welcome you, sir, once more to our meetings. So as Jyoti told, we are celebrating National Science Day with a week-long programs. So today we are fortunate to have Professor Verma leading a teachers training program on properties of light. So along with Professor Verma, we are also with us Mr. Amit Kumar Bajpai, who is Chief Coordinator of Personal Relations, Shiksha Sopan, IIT Kanpur, and he is also the Program Coordinator of SGM IAPT Anveshika of Kanpur. Welcome to you, sir. My hearty welcome to all the teachers who have come here. I also welcome all my colleagues who are here to attend to this program. Special welcome to VVS Shastri, sir, who is here with us. With this, let me conclude. A warm welcome to all of you once again.
Thank you very much, sir, for this welcome address. And now, Professor Verma, sir, please, the stage is yours. We are all here with our heads and minds to your talk. Thank you.
Okay, so thank you, Jyoti ma'am. Thank you, Sanjeev sir, for giving such a nice introduction about me. I discovered many things from this introduction. All right. So there's nothing great about me. I'm an ordinary teacher. Okay. I'm not a very good researcher as well. At IIT Kanpur, I did supervise 6 PhDs and many MSc research projects. But I did not discover anything great like Dr. C.V. Raman or like that. Because somewhere in my heart, the student community of India was there. And I found that I'm not competent enough to do a path-breaking research which can benefit the larger society. But perhaps I can make contacts with these students and these teachers so that my life can be useful, productive, and something can be, at the end of the day, I will have the satisfaction, yes, I led a useful life. So that is how I came more into teaching. Although supervising 6 PhD students from IIT Kanpur does need a lot of research involvement, and I enjoyed that. I enjoyed that very much. Okay, but then I decided not to go far ahead on that lines, but then to make contact with people and teachers and students. So that's my history, and I had been an average student in the beginning in school times. Right, and since I was an average student in school time, it helped me to get the top positions at university examination, IIT Kanpur, MSc entrance examination, and scoring very well there, and getting the first position in my MSc, and all those things in research also, blah, 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 blah. All credit to my school teachers who did not give me marks. And all credit to my parents who did not ask me, why are you not getting marks? You are not getting, okay, fine. What's the big deal? What's the big deal? So now this is the serious point, I had an opportunity in my school days not to go by any narrow lane, structured lane. I had the opportunity to widen my vision. I had the opportunity to do whatever I like to do. Whatever section I want to study, I will study. If I don't like to study this section or this chapter, okay, fine. Okay, fine. If questions are arising for a particular area, I'll pursue that in my mind. If they are not arising only for getting marks in the examination, I am unnecessarily burning my brain and my heart and my physical health. So no point in that. Since I lived that life for almost, say, class 9th level, okay, just before high school, somehow I got interested in studying the books, textbooks. Otherwise, I was learning a lot of things from the classrooms. That's why teachers, I'm giving all the credit to my teachers. They were excellent teachers. So I learned a lot of physics, a lot of chemistry, a lot of mathematics in my classrooms. But since it was not directed towards the examination, it made my basics very, very strong. And one of the basics were very, very strong. When I decided to study the textbooks and write good in the examination, I could do it. Right? So that's the history of my own journey, and I really enjoy all the things till date. Now this is the light, properties of light. So in 1 hour I cannot tell most of the things, but 2-3 things. The first thing we do in our textbooks, maybe class 6 level or somewhere, when we introduce light as a chapter, what is the first thing? Light travels. Now, who does not know that? Who does not know that? The child also knows that. If you shine a say, 500-watt bulb, that flashlight, everyone does like this, right? Everyone does like this. So that light doesn't come to my eye, is blocked here. I know that it is coming in straight line. That's why I'm blocking it. Otherwise, if I don't know, it can come sideways also. Then I will not do it like this. Anyone who had not studied the chapter of light also does this. Right? When the sun is there, bright sun is there, and you have to stand like that to get a photograph clicked, then everyone is know that it is coming very straight to your eye. So either they will try to reorient yourself. Everyone knows that. But no. Light travels in a straight line is the first chapter, first section. And we teach them. How do we teach them? Not by giving the example of I have put the hand there. 3 candles. No. 3 card sheets with holes. Holes. And then look from one side. And since you are able to see that, it shows that, oh, is it so that? Does it need that kind of explanation? And who says that if you are able to see the flame, when light comes through those 3 holes which are in a straight line, proves that light goes in a straight line? Just let me put some holes here. These are the 3 holes. First hole, second hole, and third hole. And the light has to reach here. And light starts from here. Okay? So if you see that light has reached there, does it prove that it has gone through this path? It might have gone through this path. Came to my eyes. Finish. All right? So all those kind of things. Now this is the competence. Nowadays after this NAP, competency-based teaching. This is the competency that is needed. Textbook says that if you see from this side, then you are able to see the light. And since they are in straight line, therefore light travels in straight line. I should be able to question. How does that show? Right? So today we will have some glimpses of some things which you generally teach. Amit bhai, you will do it or I will do? I can do. Wait. So, you have a container and you have a pencil and I'm putting the pencil in this container like this. And everyone says that, okay, the pencil is very good, very nice, cylindrical object, perfect cylindrical object. Okay? What happens if I put water in it? Up to half the level. What will happen to the pencil? It appears to be bent. Very good. You know everything. Good. So here is water, and here is the pencil. And sir, you will tell me, no one else. Okay, I am putting the pencil. Okay, is it bent? How come? Is it bent? No. But you said that it bends. It doesn't bend. It appears. That is the meaning. I see it bending. But you are saying that you don't see it bent, right? That's the meaning of appears to. You know that it doesn't bend. It's a rigid body. Unless you break it very hard, it will not break. You know that it's not bent. But then you say that it appears to be bending. But does it appear to be bending? You don't see. Okay. And this is attributed to refraction of light, correct? Refraction of light. So that means for some people there is a refraction, for some other people there is no refraction. So Madam says that since I am seeing from this direction, I am sitting in this direction, that is why it appears to be straight. All right, so let us do it again. No? Yes. Yes. It bends. It appears to be bent. It doesn't appear to be bent. Huh? So for some people refraction is taking place. For some people it's not. Okay? Now from the front side also, do you see it bent? No? Really no? Okay. Yes. Yes. Okay, I will not shift it. Yes or no? Yes? Yes? For everyone. What happened? What did I do? What did I do? Right. So what did I do? If I have, say, two objects at a certain angle, suppose it's like this. Now, if you see from the front, okay, then you don't observe from you. Can you see that there's a bending here? From the bottom, there's a back seats, and you are able to see that my finger and this pencil are not in one straight line. Can you see that? But people who are sitting there, they are not. But if I do this way, everyone, correct? So that's the story about it. One more thing. Now when you see the bending, you tell me, okay. Can you see the bending? Now tell me whether it is the part which is dipped in water, whether it is going away from the normal or towards the normal? Away from the normal. The part which is in water, look at that. Towards, is it bending this way? The normal is this vertical. So do you see it bending this way or that way? Away. But light when goes from air to water, it's bending away. This is bending away. Huh? How come? How come? Huh, observe from
Light is
anywhere.
traveling from denser to rarer, whereas from here it is moving from air, rarer to denser. It all depends on
But,
from the point of observation.
right,
Where we are observing.
right. Okay, very good, very nice. So the pencil which is inside the water, सर थोड़ा कैमरा और पीछे जा सकता है क्या? हैं? मैं उन लोगों को एड्रेस नहीं कर पा रहा हूँ जो पीछे बैठे हैं, मुश्किल है, मुश्किल है. हाँ, आगे अगर नहीं आगे तो पूरा भर गया. ओके, चलो. So that means the direction of the pencil is not the direction of the light. The pencil is appearing bent, but the light is bent away from the normal. But the light is bending towards the normal. Okay, these seats are available, right. This is the VIP row. Free of cost we are offering. No, please be here. Well, some 3 are here also. Okay, fine. Good. Right. So, although the light is bending towards the normal, the pencil in the water is bending away from the normal. So, why it is bent? We observe. Okay. Okay. Right. Easier way, not taxing too much of imagination. Anything here appears to be lifted up. This is a very common phenomenon. And whatever. And you can very easily explain that also by light bending away from the normal. That if it's more diverging when it comes out in air, and then it converges at a point above the real object, so it lifted up. So the pencil which is here, पानी खाली कर दीजिए. The pencil which is here, dipped in water, this portion, okay, this portion, ठीक है, ऐसे ही करते हैं. This portion which is dipped in water, this will be lifted up when I see from top. This will be lifted up, this will be lifted up. But this is crossing a lot of water height. So it will be more shifted than here, where the height is less. Okay? That shifting also depends on how much of water is there. If there is very shallow water, then you won't find any significant shifting up. But if the water height is this much, yes. If it is further up, yes. Since the bottom from here, the water height which it has to cross is larger. So the shifting will be more. From here shifting will be less. From here shifting will be less. And at the surface there won't be any shifting. And therefore your pencil appears to be bent away. Okay? ठीक है? Right. So you can play with this. You can play with these things. Now here's a plane mirror. We'll do a lot of things with this plane mirror. All right. Then here is this torch, green laser torch. What are you able to see Are you able to see something here? Something here? All right?
Now? Little bit? And now? What is this? Reflection. We can change the angle also. So, incident beam and reflected beam also change with normal. And suppose if I can do like this, can you see the path of the light? Where light is going? From this side to that side? Light is going from a straight path, but how you can see?
You are able to see.
You are able to see the light now? Can you see the path of the light? But the light is going from this laser to that side,
Wall.
that wall. Yes, because of scattering. So how scattering is take place?
It should be some, right.
Is absorbing, re-emitting the light. Yes. So you can demonstrate this reflection phenomena with the help of laser and this mirror and some powders,
Talcum powder.
talcum powder. So
Okay, good. किसके लिए? Incident light, incident ray, reflected ray, and normal are in the same plane. Okay? So here is the mirror, and here is the incident ray. Here is the incident ray. Okay? There will be some reflected ray. Now tell me by putting your hand or your notebook, where is that same plane? Incident ray, reflected ray, and normal are in the same plane. So I want to identify where is that plane, that same plane. Where is that same plane? Okay, wait. Yes, madam. Yeah. Show it. No, the diagram. In this physical situation, you have this mirror, this is the incident ray. You know where will the reflected ray go, and then you say that incident ray, reflected ray, and the normal are in the same plane. So you physically show me that plane by putting your notebook there, or your hand there, or somehow you have to show that, look, this is the plane, this is the plane, this is the plane. Okay? Wait. Yeah, you can say that. Okay, this is the plane. 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 Where is the plane? Plane बताओ. Huh? Yeah, this is the point of incidence. This is the plane in which you see the incident ray, reflected ray, normal are in the. Where is that plane? Show me the plane.
And it's like this.
This surface itself is the plane. Very good.
Perpendicular. No,
Huh?
perpendicular to that mirror.
You show it? Okay, from this hand, he is trying to show with the hand. Yes.
Like
All
this
right, like this.
perpendicular.
Good. Very good. Where is that plane? Put your hand or your notebook or your mobile phone. Where is the plane? Where is the plane? Yeah. You think this is the plane. Okay, very good. Huh?
Flat surface.
Yeah, it's the flat surface. This is also the flat surface. Okay? So, these kind of small probing questions can enhance the thinking power of the students. Okay? And this culture should be there. Whenever the student listens these words in the same plane, the students must, this question must arise. If the question is not arising, the
if the student is not asking back, where is that plane? That means the entire teaching exercise that we are doing is not in the right direction. So these kind of probing questions will stimulate that thinking process again. It should come naturally. If I say they are in the same plane, then the immediate natural question, where is which plane? Same plane means which plane? So that should come into the thing. So that is how these small things can. Yeah. What is this? And when do you use this ambulance in your optics course? To teach lateral inversion. And what is lateral inversion means? What does lateral inversion means? Right becomes left and left becomes right. Okay, good. So, okay. Let me first look at myself. कैसा है ना? Ambulance. I have some perfect. Okay. Yes, good. Now, can you see the actual ambulance and also the reflected image in the reflection?
Yes.
Are they inverted?
No.
Why?
So the reflected thing is there in
Huh?
Our back section is a reality. What is in the back is the back side. Reflection is happening from the back side, not from the front.
पीछे में लिखा हुआ है. ओके, दो बार पेन चलाया है हमने. दो बार मैंने पेन नहीं चलाया है. ट्रांसपेरेंट पेपर है ना, तो लिखा हुआ आप इधर से भी दिखेगा और इधर से. So the mirror is not making any lateral inversion. Why?
It is.
It is.
This side. Back side. Back side.
one is we are getting.
इधर से दिख रहा है.
बैक साइड का इमेज दिख रहा
पेन. तो इसको मैं इधर ले लेता हूं. ये जो आपका ढक्कन है, the cap of the pen, लेफ्ट में कि राइट में? आपके लिए?
मेरे लिए लेफ्ट.
ओके. अब कैप किधर है? कहाँ इन्वर्शन है? Left does not become right. Right does not become left.
With respect to the mirror, it becomes right, doesn't it?
मैं आप बोलते हो ना, देखना तो आपको है. देखना तो आपका
है.
है.
विद रिस्पेक्ट टू द मिरर, मिरर से देखेंगे तो ऐसे.
तो आप मिरर से थोड़ी देख रहे हो, आप तो आंख से देख रहे हो. एम्बुलेंस का जब आप एग्जांपल देते हो, तो क्या स्टूडेंट को कहते हो कि तुम एम्बुलेंस पर चढ़ के देखो, एम्बुलेंस के फ्रेम में जाके देखो, मिरर पर जाके देखो? वो तो जहां से हम देखते हैं उसी के लिए बात करते हैं ना. हम तो बाहर से ही देखते हैं. हम तो बाहर से ही देखते हैं ना. तो यहाँ मैं क्यों मिरर के साइड में, मिरर के रेस्पेक्ट में, मिरर पे जाके मिरर देख रहा है, इसलिए मैं देख रहा हूँ. मिरर का देख.
With respect to the observer that is in the mirror.
आप देख रहे हो ना, आप सीधा देख रहे हो ना, आपका पेन है ये, ठीक है ना? तो आप अपना पेन में देख रहे हो, द टिप ऑफ द पेन. Lateral inversion means left becomes right, right becomes left. Now your tip is towards, and in the mirror, left did not become right, right did not become left. Left remains left, right remains right. Okay. That is not lateral. Oh, this is also lateral. Yeah, this also. See, lateral means in the same plane once again, parallel to the plane, and then normal means perpendicular to it. So whether this is also in the plane, this is also in the plane. So here also, the tip is in the mirror. Where is the inversion? The inversion is here. The tip is towards you, but the image, the tip is away from you. This is inversion, but this is not lateral. Okay, you can see the inversion. The tip is towards you, but in the mirror, the tip is away from you. This is inversion, but it's not lateral. It's perpendicular. Normal direction में हो रहा है ना, parallel to the surface कुछ नहीं हो रहा है. But जब एम्बुलेंस का गाड़ी बनता है, उस पे पेंटर को कहा जाता है लिखो, तो ऐसा वाला लिखता है. ऐसे लिखता है ना, ऐसा वाला लिखता है. आपको याद से पढ़ रहे हो तो आपके क्या उल्टा लिखा हुआ है? Why उल्टा लिखा हुआ? Because the driver of the car which is ahead of the ambulance, उसको सीधा दिखना चाहिए. और वो उल्टा को सीधा कौन बनाता है? मिरर बनाता है. कौन सा मिरर? जो कार में लगा है. वो किसके लिए बना है? वो ऐसा किसके लिए बनाया है? वो कार के लिए जो मेरे आगे है, जो पीछे है उसके लिए नहीं बनाया है. जो आगे कार है उसको मालूम पड़ना चाहिए in that side mirror that ambulance is coming and written AMBULANC in the right fashion. तो वो उल्टा फैशन में लिखेगा. ठीक है ना? तो कुछ तो हो रहा है. Something is happening. नहीं तो क्यों लिखता है ऐसे? सीधा अपना एम्बुलेंस लिख देता. मिरर तो कुछ करता नहीं है, लैटरल इन्वर्सन करता नहीं है, उसको भी अपना सीधा दिखाई पड़ता. राइट? नाउ सीधा की उल्टा, सीधा की उल्टा. राइट, वेरी गुड. अजय सर, अब यू और मी नहीं रहेगा, केवल मी रहेगा. आए उल्टा के सीधा, उल्टा. आप उधर चले जाओ, it becomes सीधा. So that inversion is not because of anything else. The person has rotated head by 180 degrees. If you are seeing from this side, no mirror. If you are seeing from this side and you go there, or other person who is there, for these two it will be different. Now think of the ambulance scenario. The person who says that the actual writing is ulta, in which direction his head is? There's an ambulance.
In front.
Okay, so there is an ambulance. Okay, there are the holes. The holes are very good objects. All right. So here's the ambulance, right? And here's the car. Now tell me, who says कि इस पे उल्टा लिखा हुआ है? वो आदमी कहाँ है? Front of ambulance. उसका head किधर है? इस डायरेक्शन में. And who says that okay नहीं सीधा मुझको सीधा दिख रहा है? कौन बोलता है? ड्राइवर का सिर किधर है? तो ड्राइवर का सिर ऐसे है. जो बोलता है एम्बुलेंस उल्टा लिखा हुआ उसका सिर ऐसे है. तो वो तो इन्वर्शन तो हो ही जाएगा. इन्वर्शन एक उधर से देख रहा है, एक इधर से देख रहा है, एक ऐसा करके देख रहा है और उल्टा लिखा हुआ है, एक ऐसा करके देख रहा है नहीं सीधा लिखा हुआ है. अरे आप टर्न कर जाओगे तो इन्वर्शन तो हो ही जाएगा. मिरर का क्या दोष है? या मिरर को क्यों क्रेडिट दे रहे हो? अगर क्रेडिट दे रहे हो तो नाजायज क्रेडिट दे रहे हो, और अगर उसके ऊपर आप इल्जाम लगा रहे हो और तुमने इन्वर्शन किया है, तो उस मिरर का मुकदमा मैं लड़ूंगा, उसने इन्वर्शन नहीं किया है। लेफ्ट का राइट नहीं, द ए वाज एट लेफ्ट, द ए इज स्टिल। आप टर्न कर जाओगे तो लेफ्ट का राइट हो जाएगा, तो नेचुरल। इफ यू टर्न योर हेड, what was left will become your right. And the people who are seeing ambulance in the reverse and the person who is seeing the ambulance straight, their head orientations are 180 degree apart. So inversion तो वहां से हो रहा है ना. The mirror has no business in this. Okay. अब ये सवाल क्यों नहीं उठता है? Well, people are not able to question this. अपने को वो कल्चर डेवलप करना है ना. We want competent people who can think, who can look at things comprehensively and analyze it. वैसा कॉम्पिटेंस क्रिएट करना है क्लासरूम के अंदर में अपने स्टूडेंट्स के बीच में. ओके, चलो नेक्स्ट. Okay. Now there's not much of discussion here. It's just a demonstration, and you might इसको ये करना है क्या? Or this is a very common thing, and you must have seen all that. But I'll just point out certain things. You have water here, and some fumes will be put above the water, and then the light will be sent, and you will see the reflection. Where did he put that burnt matchstick? Did you see? Burnt matchstick. He bent on that side. In the water. Be very careful. Whenever you do some experiment in a classroom where this fire, even if it is a small matchstick, please keep water in some container and put that burnt matchstick there itself. It's not that it will catch fire otherwise, but it is to instill the culture in the students. That culture is important. Okay. ठीक है. Right. So light goes in, and light goes in. Alright. So you have light is going from air to water. Can you see that? Light is अपना हाथ बचा के रखना. It's your responsibility. So apart from this incident light and refracted light, are you able to see anything else?
Reflected light.
Reflection. Reflected. Okay? In the air also you are seeing a reflected beam, and in the water you are seeing transmitted, refracted beam. Right? When it comes from here, apna, you take care of your eyes, your own eyes. So, look at this. Can you see three rays? Yes. Incident, refracted, and reflected. Which one is most intense? Which one is least intense? Reflected. So a small portion is reflected, and largely it is refracted, and these things go together. Reflection and refraction go together. In our textbooks, there will be a chapter or a section with the heading Reflection of Light. And the picture, the diagram will show, and there will be another section, Refraction of Light. and the diagram will be but they are always they go together. Okay, they always move. Now another thing you watch in the same setup. In the same setup. Look at the reflected light only. Concentrate on the reflected beam. Okay? I am turning my torch and making this much more. The incident angle is much larger. So can you see anything? Intensity of the reflected ray. If I put it here, will you be able to see? Or I can also go to the. See the intensity here, reflected ray. And see the intensity here, reflected ray. Increased? Look at this. Look at this. And look at this. Look at this. Okay? So the intensity of reflected light, reflection and reflection both are taking place together. Both have, but the intensity ratio is different. What is transmitted and what is reflected on candle light. The intensities are different. So two things we are missing in this chapter. One is that reflection and refraction go together. And number two, the intensity of reflected light increases as you increase the angle. Now let's do something. नहीं उनका उसी से करते हैं, किसी का ले लेते हैं demonstration purpose. हाँ, it is true for mirror also, because in mirror, from where, why do we silver it on the back side? So light goes from air to glass, then goes to that silver surface, then reflected. Now when it goes from air to glass, refraction. So that time is there a reflection? Yes. But if you don't silver it, that reflected beam is still coming, but you are not able to see your image of the face. You cannot do all kinds of hairstyle and other things. That silver is not there. From the front surface, light is reflected. But if you are looking at the image and your own face, the light is going almost normal and coming back. So the angle of incidence is almost zero, close to zero, right? If it goes at certain other angle and then reflect, some other person will see your image, you will not see your image. But if you are seeing your image, that means you are using that beam which is going almost zero angle and then reflection and then reaching your eye. But that you are not able to see the image tells you that the intensity of reflected light is very small. Most of the light is transmitted, goes into the glass. The silver is not there, that will go, that will not, so you will only get that small reflection near normal, that much, and you will not be able to see the image. That silver is to send that refracted light back to the surface of this glass appearance. And once again, a small portion of that will be reflected back towards the silver, but that will be a very small portion. Most of it is transmitted. Now the transmission is towards you. From the silver, when it reflects, travels in glass and comes in air and goes in your eye. So this is a refraction, and refraction intensity is very high than the reflection. So most of the light which you send from your face to the mirror, once it goes into the glass, then it gets reflected from the silver and then comes back. Again refraction, most of it is reflected, only very small portion is reflected. That is why you silver it. right? So mirror also that works, that incident angle and the intensity. Now, uh, I am just demonstrating, and you will do the activity. Torch on that. So all of you have some notebook, right? So what I say is, all of you will take the notebook is like that. Sir, आपका ले लेता हूँ, उनको छोड़ देता हूँ, उनको भी करने दो. And then put this torch above this, like this here. Are you able to see the image of the bulb, of this torch bulb, in the paper? In the paper?
No.
No. Now, stretch your hand, mobile phone, and then up, height up, and then your notebook in the plane connecting your eyes and the torch, almost grazing. Almost grazing. Adjust the orientation. Adjust the orientation and check if you are able to see a bright spot image of the bulb in the same leader. Huh? How come? Your torch is here. Your torch is here, okay, and up above eye level, and eye is here, and from eye to torch, in that plane you bring your notebook and adjust its angle and see if you are able to see a very bright spot. Of course, some illuminated area will be there on the paper, but still you can see that shining image of this torch. From this side you won't be able to see, and we have to, yeah. Same opaque paper, which does not make any image when the torch is right above it, but it makes a lot of very bright image when the plane. Again, because by doing this, you are almost sending it parallel to the surface. It almost reflects parallel to the surface with a very small angle there. Angle of incidence from the normal is very high, close to 90 degrees. So although there are irregularities in the paper, it is not unidirectional, but whatever is in the right orientation, that's the difference between opaque and this transparent. If it is transparent, it's a plane surface. Then all the parts are in the same plane. But if it is rough surface, then somewhere it will be like this, somewhere it will be like this, random variation. And therefore, the beam does not reflect in one particular direction. But then, the parts of this paper which are correctly oriented, so that from the light to torch, it can reach your eye. If these two things are fixed, this is the object and I want my light here, then you know how to orient this mirror. Correct orientation, if this is also fixed and this is also fixed, the 2 points are fixed, and light from here should go, reflect and reach here. You can do that, right? You know that you have to put the mirror in this orientation so that angle of incidence is equal to angle of. So the portion of those rough paper which are rightly oriented are sending the light preferentially with a higher intensity towards the eye. And you see the image from that. So it relates to this experiment where you connect the intensity of light and the angle of incidence. Okay? Yeah.
Sir,
in diffuse, yeah, that is true. But in this reflection, your surface of this what surface I see, wall for example. But if you look at small portions of that, then the orientations are different. But for each orientation, for each particular light falling on this small area, whatever is the orientation, that decides the normal, and from there I is equal to I. So that the law of reflection is obeyed in this diffuse reflection also, but all the mirrors are not in the same plane. The mirrors themselves are oriented randomly here and there, and therefore a lot of light is going this side, that side, and everyone can see. That's the benefit. That's the benefit. If the light goes there, and then everyone is able to see, okay, that's the nail in the wall. There my coat is hanging. Otherwise, only one person will see that my coat is hanging there. Okay? Yeah. Now, without any explanation, we will show you something. There are two drawings, not as good as you can do. Shastriji can just sit here and make a sketch of everyone who are sitting in this room. Okay, so there are two sketches. One is in which color? Other is? Right? And then I have a red. Yeah, it will act like a filter. It will absorb other colors preferentially. Not all colors will be absorbed anyway. And red preferentially it will transmit or reflect. Okay. So if I put this sheet on this drawing, what do you expect?
Only red one will be
Red against red background.
Okay. This was the original drawing, and this is after passing through that red filter. So the red is disappearing, and is the blue still blue?
No. Somewhat blue.
Somewhat. Look at the blue one, and look at the blue one. Blackish. Okay. Good. Very good. Now I have another drawing here. All right. Once again, red and blue, and I put the same filter here.
See, before it was just a red background, but here we have black background.
White background.
That was white background. So now against white it is looking red.
Good.
But here black.
Good. So this demonstration, we are not going into the theory, what is absorbed, what is reflected, but this activity, small 2 minutes activity, has triggered you to look at more details and say that the background, this is white background, and there is a black background which is playing the role. It may not. It may or it may not, we don't know. But you started thinking on it, what's the difference between this side and that side. Why here it is behaving in a different fashion, and here it is behaving in a different fashion. So you started thinking on it. You came with a solution. Okay, is the background which matters. Now further investigation can be done to verify whether you are saying right or wrong. But the purpose of making you think is already served. Huh? So create situations in the classrooms where students are given opportunities to think. They have very fertile minds. but they are not exposed to such situations, so that they apply their mind to look at it. Nobody is telling. This is our natural process of learning. This is our natural process of learning. Before coming to school, nursery at the age of 3 years, nobody teaches. Nobody teaches the child. But he knows not something, lot of things. He knows a lot of things. He learns a full language. Learns a full language. He learns to distinguish between a male and a female from the dress. He learns distinguish between two people with different age groups. He knows whom to say uncle and whom to say baba. Okay? He knows that. Or whom to just say, hello. Same age group. Many things they learn. They know that the light is traveling in a straight line. The many things they know. Huh? That's a natural process of learning. They see the events. Those small kids, 6 months, 9 months, 1 year, 1.5 years, 3 years, and then it appears. This is a natural process. If they see the event, then analyze it in their mind. And if something happens again and again, they find the connection, the commonalities, and they form the rules in their mind. Okay. From the falling objects, they learn that okay, everything which is dropped will go down. That they have learned by seeing different repetition of such events, and then they come out with the rule that okay, if something is dropped, it comes down. And when they see something put in water and it floating up, they revise their rule. There are some things which go down, and then so there are some things which come up. So they keep revising, they formulate, they validate. If it doesn't work, they make new rules. All this is the natural process of learning. So driving into that narrow lane of textbook curriculum, syllabus, examination, that driving kills this natural process of learning. It's always there. It is not killed actually. It becomes, it goes behind the screen. Even now, you see the event and then you start thinking and nobody tells you, you analyze that, okay, background is white and here background is. So that natural process is still there, everywhere. We should cash on it. We should use this as a strength. We should nurture it further. To create the situation, they will come up with this. Alright? Okay. So, this is one session. Demonstration session. I hope you enjoyed that. Very good. Now the second session will be the second session will be this, which we call lepton. And you know, lepton is a class of elementary particles. Electrons and bosons. No, not bosons is particles. So learning physics through nature. That is it. So here he will, yeah, charge.
Going to play videos one by one, and videos length is very short. It is around 30 seconds, 40 seconds. You have to observe the video, watch the video, and after that we have questions related to the video. We are providing some answer sheets to you. You can just tick mark and submit to us. After that, Verma sir will discuss one by one. Is it okay? So these videos are related to our nature and very common videos which you have seen day by day, means in your daily life. So I am just going to show one video first, and after that second and third. So are you ready? We are just providing some answer sheets ma'am is coming to distribute you. Yeah.
So should we provide them before or like in the
Before.
after this? Before. It's coming in a while.
Okay. So I'll just projected one video. So please wait and see.
Are you able to see? Okay.
So we have questions related to this video. Can you tell me what you observed? आपने क्या क्या देखा? Yes. Not visible first. Other angle, lateral visible. Distance was covered there. कौन सी distance? Which distance you want to this?
We went further towards the board and then we
Change the angle. Okay.
intensity also.
Intensity also.
The rays is coming from
The rays is coming from more,
the window.
more from the window.
The board and then
We can lace.
At one angle, the board was shining.
Torch experiments we did earlier. It is same phenomena happened on the board. Okay. Yes, yes. Please distribute. I will collect all the answers. Yes, ma'am. You want to say something? No.
At one angle, the board was shining. The other angle, it was not shining.
It is not signing. So when board is signing, then that time we see physics is written over there or no? That time you. Huh? Okay. So let me just question related to this. So this is question 1, board signing 1. Light from the window is falling on the board and reaching the camera. Backside, are you able to see?
Yes.
Can you read all these things which are written? Otherwise, I am just reading. Case 1, when the word physics is not visible. Case 2, when the word physics is visible. It means it is having two questions. In case 1, A, no light coming from the word physics is reaching the camera. B, light is always reaching the camera from the word physics. C, light from the window falling on the word physics and its adjoining areas are of nearly the same intensity. D, light from window falling on the word physics and its adjoining areas are of different intensities. No substantial regular reflection from the board is reaching the camera. So, one or more answers will be corrected, may be corrected. There is an answer sheet and A, B, C, D point is written. You can just tick whatever you want. Next question. Next question is also related with the same video. The video is same as in the previous question. In case 2, A, light reaching the camera from the word physics and its adjoining areas are of nearly the same intensity. Light reaching the camera from the word physics and its adjoining areas are of different intensities. Light from the window is not reaching the board. A substantial regular reflection from the board is reaching the camera. I think same questions for case 2. Case 2, what is case 2? Case 2, when the word physics is visual. And question related to case 2, these are the options. Next video. Case 1, room lights off. Case 2, room lights on. I am playing again. Questions? In the video, a person is standing with a lit candle outside a room whose glass door is closed. Let the amount of candle light reflected and transmitted from the glass door be R1 and T1 in case 1 and R2 and T2 in case 2. Respectively, mark the correct statement. R1 is greater than R2, R1 equal to R2, T1 is less than T2 and T1 is equal to T2. Next video. questions? Refraction by glass slab 1. Treat the lighted path on the paper after the slit as a narrow light beam. The paper is fixed on a horizontal table. Let A be the point where light falls on the slab and B be the point from where the light emerges from the slab. The normal to the surface of the slab is vertical at A and horizontal at B. Is vertical at B and horizontal at A. Is horizontal both A and at B. Is vertical both at A and at B.
Excuse me. Sorry, could you please explain what you mean by vertical and horizontal?
Can I repeat the video? Okay. Table is horizontal. Next video. Wait. Yes. Question 2 for refraction by glass slab. The video is same as that for the previous question. You can see in dimmed light condition that a part of the incident beam is reflected at the first surface. The acute angle made between the incident beam and normal at A is x. That between the reflected beam and the normal at A is y, and that between the emergent beam and the normal at B is z. Mark the correct options. 2 lens video, mark the correct options. Lens A is convex while B is concave. Lens A is concave while B is convex. Lens A and B both are convex. Lens A and B both are concave. Please submit your answer sheets. After
So
that,
can you
we will
please
discuss one by one.
display the first question again?
So we start from this question, and since time is approaching, we'll go fast. Okay. So the first one was definitely convex because it was creating inverted real image on the screen. When the second one was put, it was taken away. Right. So that means this combined focal length has increased or decreased? Focal length. Yeah, focal length has increased. Power is decreased. So with convex, I have to put concave, then only the power will decrease. So that's it. Right, right. Okay, so the two normals. Horizontal. Good, good. The question should not be invincible. Huh? If you want to test the student on certain concept, the best thing is to first test or to give a question which you know that everyone knows. So that gives a moral boosting. Yes, I have done the first one. So the second one also I should be. With that spirit, the person will think on the second question. I don't know. I have just learned these things with experience. No training, no beard, no MA, nothing. And I know these things work. Right? That is the spirit with which you treat, the mindset, all these things matter in actual delivery. Yeah, next one. Now this is the acute angle made between the incident beam and the normal at X, and that between reflected beam and the normal at A is Y. So angle of incidence is equal to angle of right, good. And then the other one is Z. So the emergent beam and the normal. So since the ray is only parallelly shifted, so the normal here, normal there will be all same direction. So Z is also equal. So X and Y and Z, everything is equal. But this question has a different goal. One is that they should know that it is parallelly shifted, it doesn't turn in a slab. So those things are very much there. And then of course, but this sentences, this paragraph, it's a kind of comprehension. It's a comprehension test. It's not straight question, angle of incidence is equal to reflection, yes or no. It's not straight. You have to understand that this is a simple question. It is a simple question, but you have to read and understand, okay, this is the thing that is being asked. So this was to see if people can read a text, read a paragraph and understand it. That was the goal for this. Alright? Yeah. Yeah, case one, room slide off. Then case two, light is off. You can see that image is not that sharply seen when the light is. It's very common experience. Right, the questions are in the video, a person is standing with a lit candle in a room, outside a room, whose glass door is closed. Now R1 and R2, let the amount of candle light reflected and transmitted from the glass door is R1 and T1 in case 1 and R2 T2 in case 2. So what we are asking? Light which is getting reflected from the glass door and transmitted. So the light which is going from the candle, light, let the amount of light, candle light. So candle is sending same amount of light, whether the inside room is the bulb is there or not, and it is going at the same angles and everything same. And what is the angle of incidence? Depending on that, the reflected intensity will be decided and whatever. So the candle light is doing the same job, whether the inside light is off. Okay, so that was it. Right. Board shining. When the word physics is not visible, in the case one, board is shining. The board is shining, physics word is not visible. No light coming from the word physics is reaching the camera. Why not? Why not? Alright. Light is always reaching the camera from the word physics, yes. Light from the window falling on the word physics and its adjoining areas are of nearly same intensity. That is why you are not able to see. Okay. The light which is coming from that area after reflection, a lot of light is coming, and then from the physics also coming, and since there is no contrast, and so you are not able to see that. And then light from the window are of very different intensities. No substantial regular reflection from God is reaching the. This is also wrong. A lot of light is being reflected in the proper this angle. So that is the kind of regular reflection. This is it. Case 2. Almost same options perhaps are same. Light reaching the camera from the word physics and its joining areas are of near. This is wrong, correct? Because it's a white chalk and a green board. So white is reflecting more and green is reflecting less. That is why the contrast is there. Color is also different. Light reaching the camera from the word physics and its adjoining areas are of different intensities. Then light from the window is not reaching the board. I am only shifting the camera. I am not shifting the window. And I am not shifting the board. Okay? And then substantial regular reflection from the board is reaching the camera is wrong now. Otherwise it would have shined. So, next. Okay, done. Alright, so let me just tell you in a very brief. These videos are part of a national competition that we conduct every year, which we call National Anveshika Experimental Test, NAEST. So this is done every year, and the first round is like this. The first, about 25,000 students normally register for that. It has reached 56,000 also at certain year, COVID time in fact. When people are looking for what to do. Alright. But out of those 25,000-30,000, the first screening is through such questions. We have generally 10 videos and 18 questions. So they are from our previous year questions, optics questions. We have taken 4 or 5 of them. So this is our first round of that NAEST. The second round, the selected 1,000, around 1,000 students are selected. Those are given a write-up where a description is written to perform some experiment with hands at their own home. But we have told that this is the experiment you have to do, not that everyone is doing something. So this particular, you have to find the surface tension of the water using this particular way you make the drops and blah blah. So some summary type of thing will be there. But then the restriction is that everything has to be done in the house, not in the school lab, and no lab apparatus is allowed. Anything you use, either it should be available in your house or it can be purchased from a stationery shop or a grocery shop, but not a scientific store. So we design such questions, 3 experiments, and those 3 experiments are given to the students one by one. For one experiment we give 1 week of time, because they have to design the apparatus also. They have to assemble, they have to design, they have to search for what to use to do this. Okay. So that is the thing. Then they send the report in a PDF file, and then we evaluate. And normally some 150, 180 teachers are involved in that evaluation process, because it is non-standard. We do not have a standard answer key that if it is written this, find this marks and so on. It's very subjective, and the teachers should be competent enough and experienced. They should have the experience that if you are designing an experiment, designing is the experiment is given, but you are designing the apparatus, how to do that, and then performing on that. So that's a separate experience. So all those evaluators, teachers who are involved, some 150 we need, and some people always leave. We always look for the new evaluators. So this is an appeal to you also. This can be part of it. What it means? It means something like 2 weeks of your time. 2 weeks of your time, say on the average 1.5 hour to 2 hour a day. So that is the, and this will be probably in June, July period. So if you are willing to come to this team of evaluators, then you can contact me. We will give the email address here. You can contact me. We will send you a small experimental write-up, not very involved, very small, which you can do in half an hour. So you perform that and send the PDF to us. That's the entry for this evaluators. You have to get some experience of doing this thing. All right. After that, we select from 40, 50, and we bring them to my Kanpur house, and they perform a lot of experiments there, and final things are done. The math webinars are done. All right. So that's all.
Hello. So thank you, Verma sir and Amit sir, for conducting such captivating performance, like some of the demonstrations we got to see, and a very good taste of the understanding also through these questionnaires. I hope it prompted us further and also made us, more excited about the subject. So thank you once again for the first part of this program. We had the demonstration and also the lepton session. And now we all will go for the lunch. So the lunch time is between 1 to 2. All are requested to go to the canteen area, which is on the 4th floor. Our science communicators will be guiding. They are sitting on the back side. They'll guide you. You must have already, a lot of you had visited the 3rd floor area today. So it's the next floor over there. So you just have your lunch and please come back to the same auditorium. So we will be guiding you from here, and then we will begin the teacher's hands-on experimentation session after lunch. So thank you very much once again for all your attention, and yeah, please head on for the lunch. Thank you.
So we are going for the next experimentation session, but before that, Verma sir would like to explain some more aspects on the subject. So, sir, kindly take over the session. Thank you.
We have set up 2 experiments there which you can perform, and 2 people will do it on one set. So on the table there are 4 chairs, 2 on one side, 2 on other side. These 2 will use half the table and these 2 will use the other half. Okay. Then the first experiment which is there you are given some amount of this, what is it called? Clay. So on each table, on the 2 sides, for each experiment, you are given this kind of clay. You are given a lens, convex lens, with a convex lens, and then you are given 2 erasers, and then you are given 2 toothpicks, right? So what experiment do you think I am planning? Image formation, and then removing or locating, no, locating the image. So image pin and the other pin which locates where the image is by removing the parallax between the real inverted image and the other pin that you have in your hand. So the experiment, everything is generally done in the schools, regular classes. Now this lens has to stay vertical. For that you will be using the clay. In the clay you will put it here, and then if you put it on the table, it can just stay there, right? So that is one part. And once the lens is staying here, and this eraser is to make that pin, right. वहाँ पे खोल के रखा है या उसके साथ okay. So what you will get is a cleaned razor, not with the wrapping and all that. So this pin can be this pointed end will go into it, and then you will be adjusting the height of it so that the tip, it's not the tip has gone down, but now this is the tip. So this will be at the level of this center of the lens, so that's one. Similarly for the other pin, the other part also you will be doing the same thing, and you will get a pin there. Pointed actually. Now the main thing is, one thing is that you don't need optical bench. For doing this experiment, you don't need actually the optical bench. You can have this cheap setup and it can be done anywhere. Only the lens is one critical part. Now, but the practice is to do that how do we remove the parallax? If I see it from this side through the lens, then this pin which is here, object pin, I will have an inverted image here, and that I can see from this side that there is an image inverted hanging, and there is a real image. But then to locate that, we use this other pin and we put it at a place so that there is no parallax. Now, what do you mean by no parallax? If there are these two things and you are sitting on this side, then either it can be that your locating pin is here and the image is here, or it could be the otherwise, right? And the test is that if it is the right one over the other, and then you move your head, then they go together. They do not separate. But if it is like this, from this position, if you see that they are touching. They are touching. But when you move your head little right or little left, then you see that they are separated. So you have to find that position where it's not separated when you move your head. It's very simple. But then trial and error, generally people shift the head left and right, and the pin is going ahead and back and like that. So that gives a lot of trouble, and ultimately the parallax is actually not removed most of the places. So the students have to be given a right kind of a guidance, and what I do is, first I go in the line of these two, whatever. This is the image hanging like this, and then there is another pin that I have here, right? And then it can be this way or it can be this way. So in the same line I go, whether it is this way or it is this way or it is touching. I will see that they are touching because I am seeing from that same direction. So little few millimeter this side or few millimeter this side, we won't be distinguishing, and it will look like that they are touching each other. Now, what I ask people to do is shift your head little bit on one direction and stay put there. Don't oscillate. Just one single displacement, and then analyze. Now you are seeing the two as a separate pins. They are not touching. So one will be, suppose you have gone left, your left. So when they are separated, one will be at left, one will be at right. So that means one is going in the same direction after separation. It is on the same direction in which you moved your head. And the other one is going opposite that. So watch whether the hanging image is going towards you, with you, or it is this real pin which is there that is going. And the clue is that whatever is nearer to you will go opposite direction. If you have moved your head towards left, then whatever is going towards right after separation, that is nearer to you. When you go in train, the things nearer to are moving opposite, and the other one seems to move forward, right? So this is the way to remember also that one which is going opposite to my movement is nearer to me. One which is going in the same direction as I moved my head, that is farther. So now if you know that this pin, locating pin, is nearer, then you push it away from yourself. And you find that this locating pin is going opposite. So this was this, and if it is going in the same direction, then you pull it towards you. If it is farther from you, you pull it. If it is closer to you, push. So a small displacement you can give, and in one single go, you have shifted your head, and then you have decided whether I have to take it this way or that way. A conscious decision. And then gradually, slowly, if you go in that direction, you will find that from the shifted position also it is. But since it is not an optical bench, during this process, you can also shift it in a perpendicular direction. And then from the shifted head also, it may appear that they are touching. So to verify that, you have to do the same thing again. From wherever you find that it is touching, shift your head once again. It is in a conscious way in one direction, small displacement to your head, and just stay there, analyze what happened. So this way the right kind of practice can be given, so that this is the one experiment. And if you want, after that in your school, you can say that, okay, this is you, this is we, find here. That is not a big deal. We won't do this here. To learn how to remove this parallax, and the idea behind that, the theory behind that, that is the purpose of this. Okay. Now the second experiment is in that screening lepton. We had a video. So that same thing you construct. You have this, and it will be in a cover, right? So it will be in a cover. When it was purchased in this kind of a cover. So what you will be given is slab in the cover. Okay. So you remove this cover, and then you cut a slit from one part of the cover, right? So this is the slit. In the video, remember now? So this is the slit, right? So this slit you can make it a stand on the table using this clip. You can have this clip here, and once you have this clip here, you can just place it on the table and it will stay vertical. So your slit is there, and then this kind of paper will be given. So you can put that paper on the table, slit here, and then the mobile, you can place your mobile also in the vertical direction, right? So using that same clip, you can also make your mobile stay there. And the torch is near bottom, so that's the orientation. And then on the other side, some people might be seeing that you have this beam on the paper. Okay, so from the mobile torch, light is going through the slit and then making this mark here on the paper. So this is your light beam. And then you put the lens, this slab, and in some orientation, so that you have it's parallel shifted. So you can make a measurement of that, and you can make a measurement of angle. Protractor is given, and then you can do all kinds of calculation, and you can get refractive index on this. So you don't have to do all that calculations and all those things, but you just have the experience of using the cover of this slab. Even that is not to be thrown, because anything which is thrown, you have added carbon to the environment. Right? So even if this can be used. as many times as you can use, you should use and then throw it. So this is one. And then making the things stand vertical in vertical direction using the clips. Then getting a sharp good beam. If this is too close, you will have a diverging beam. See, you have a diverging beam. If it is too far away, then the intensity will go down. So judiciously, right, so those kind of experiences you can have, and how much this slab should be oriented so that a visible displacement is there. So those kind of things you will practice, and then you can, if you have a pencil, you can mark on this paper these beams, okay, 2-3 points. If you can just put your pencil and then join them, so you know that this is the emergent ray and this is the boundary. So angles can be measured and other things. So these two things we will have to do, right?
change one position, then do it again. Then you can keep the knob
Laptop is there. Go and check. Go and check.
Now this is going, which is going away from you, which is going towards you, which is going less from you. Don't oscillate with it. You move left, stay there, and see which has gone left, which is on the left. That means it is still farther away from you. You have to shift this pin further towards the left, right? Shift it back. You stay here. And now go left. What happened? Which is at left? That means inverted Still it is away from you. Push the spin further. Push. Now come to a position where they are touching each other. Move left and stay there. Which one has gone left? Till that knee is not away from you. Or that way. What happens now? Very slight separations, we are going in the right direction. But now, for the sake of first beginning to decide from where you are seeing that overlapping or touching. Okay, go left. Which one has gone left? Till left. Repeat. Much better. Is it still separating the first check that? Yes, yes, remove that edge. Push it further. All is clear. Yes, first check. Okay? Yes, now they are going to. Now they are going to. Yes, you have got it. All right. Check once again. Even the slightest error has been minimized. Hey. All the time they are judge which one has the one which is on left, the one which is on left, that position is this is farther.
Context of middle school, say, science class, and whenever I introduce light, I find it very difficult to kind of introduce it with a kind of an interesting hook, because light is such an intuitive experience for all of us. So how do we talk about light beyond just it's a form of energy, but at the middle school level? Because the moment you ask the question, what is light, it becomes very difficult very quickly, right? I mean, in terms of nature. What is an interesting way to introduce light so that the children can kind of look at it as a subject of study rather than, I don't know if I'm putting this correctly, because it's such an intuitive understanding that light travels in a straight line. It's difficult for kids sometimes to come out of the situation and say, what if it wasn't traveling in a straight line? How would my experience be different? So like, how do you put that intuitive experience as a subject of study, but at the middle school level is my question.
Okay. Let me try to understand your question.
Yeah. Sorry, I know, it was not very well articulated.
See, students are aware of air, correct? They don't see air, but they know that there is air. When the wind is there, then they feel, they breathe out. They know air. They have an intuitive understanding of air. Now you start from there. Light has carbon dioxide, light has nitrogen, light has oxygen and that. You are not leaving out that experience. Yes, the air is there. Similarly, everyone has this intuitive experience of light, every child from class 1. So it is good for us. We don't have to introduce any new thing. We always say, okay, you know the light. Now let's go deeper, how light travels, what light does when it falls on a wall, when it falls on a table, when it falls on a glass surface or glass slab, what decides how the light will go and so on and so forth. For air also we have some intuitive properties. When there is a huge storm or wind, then the air behaves in a different manner, all that. So there is nothing wrong in it that they already know it. How do I go ahead from there? It's good that they know it. Now you go ahead of there. What do you want to teach at middle school level? Huh?
Propagation of light.
Propagation you don't have to teach. You don't have to, light, you just tell that you know that light goes in straight path. That is why the shadows are there. That's why why are the shadows there? Light is not reaching that. Why not reaching? It cannot bend around. So फिर हो गया, खत्म हो गया, propagation खत्म हो गया. Next.
How do we see it? Like, how does light help us?
हाँ, okay, very good. तो लाइट हटा दो, बंद कर दो लाइट, आपको दिखाई नहीं पड़ता, you don't see it. Then you switch on the light, आपको दिखाई पड़ता है. The same object. That means the light must be there. और अगर ऑब्जेक्ट पे नहीं पड़े, बाकी मेरे आंख पे पड़ता रहे, तब भी ऑब्जेक्ट नहीं दिखाई पड़ता है. So that means light must fall on the object and enter my eye. If I put a block here in between, then also I don't see the object. No, if I stop the light, then also I don't see the object. So it's a simple logic. The light is falling on the object, and from the object is coming to my eye, only then I see. Right? Huh? Yeah, go ahead.
So in my physics class what I had done was, so the very first vision theory that we had was, someone had said in ancient Greek that light, our eyes have light sources, and then it hits the object and then we see
That
the
was
object.
Euclid.
Correct, thank you.
That was Euclid.
Empedocles, I think. So, and then 1,000 years later someone Persian comes and he says, no, we actually see it. Like, this cognitive jump is actually, I'm finding, not the easiest to make, because now that we know it, it seems very obvious to us. When we were having this discussion, one child in my class said, in a dark room, the first argument was, in a dark room, okay, you can't see, so that is how you know that. It's okay, that is how you know that your receivers are light. But then this kid goes, if in a dark room, I stay for 2 minutes, I can start to see things. So does that mean that my eyes have light? Right.
Very good.
Right.
Very good.
Very impressive, right?
Yes.
So that kind of argumentation becomes very hard to break.
Why to break?
In my opinion.
It's very good. I'm saying it's very good. And you are saying how to break it. No, she said that at middle school level we are not talking of retina, etc. At that level we are talking at that level. So I don't think, do you teach all that history?
I teach a little bit of history also.
Okay. Yeah, so say that initially people were trying to guess, and they made a guess that perhaps my eye is emitting light and then it falls on a subject to illuminate it. If I close my eye, then whatever bulb are there doesn't matter. From my eye, the light, people thousands of years ago, people tried to make such a theory. And to some extent that theory was workable, But later we found that no, that's not. कहानी कहो उसको बस. Right. Okay.
Here is sun, this is the day and this is night. Here is the moon. The light rays is just over this. So I can't see why can't I see this?
This light.
This light going.
You never see light. You never see light. आप लाइट को थोड़ी देखते हो. आप लाइट नहीं. अगर आप लाइट देखते तो हम पूछते कि कैसा शक्ल है उसका. लंबा है, मोटा है, गोल है, पतला है, इलिप्टिकल है. अगर मुझे दिखता है कोई चीज तो मैं पूछता हूँ ना, ओके आपने देखा है कैसा है. तो लाइट देखा है तो बताओ कैसा है, उसका डिस्क्राइब करो, उसका शेप डिस्क्राइब करो. वी नेवर सी लाइट. एंड व्हाई सन एंड मून? Why this light and this light? I can see this object. I can see the bulb, but I can't see anything in between. What is there to conclude? When you say conclusion and then two dots, and then you write, you are deviating the child from the natural process of learning. What is there to conclude by? It's okay. You know? It's an experience. Science is an experience. Experiencing the nature, experiencing the events, how things are happening there, that experience. If you have that experience, not necessarily to be worded in a sentence. Right. Yeah. So that is a misnomer, in fact. It's not visible. It makes things visible.
Sir, how to explain a photon concept to 10th grade, sir?
Okay.
Thank you, sir.
All right, this is a quantum era. It's a quantum era. Okay, so you want to introduce dual nature of light at class 10 level. Okay, at least since they have heard the word photon, they will ask you what is photon, and you would like to give some aspects. Okay, so in concepts of physics, I have given an analogy in the chapter of photoelectric effect. Maybe it may help. And the analogy is that there is a farm, and the farmer has to water this land. So one is that it takes a pipe, and then from the pipe a lot of water flows in different directions, and then it just falls on the ground. So any portion of the ground is continuously receiving the water. The other process is he has made polythene bags, some water, one bag, another bag, and the system is that if it hits the ground, it will break. Fine. Or it's not will be opened. And then he is throwing these polythene bags here and there. So for some time, this particular piece of land, for some time it's not receiving any water. Then suddenly it receives same quantum, so many grams, 50 grams or 30 grams or 20 grams, whatever he has put in all the packets. So it immediately gets that 20 grams of water. And then again, after some time it gets some other. So in 1 unit, it gets a 1 unit of water. In one go, it gets a fixed unit of water. Okay? You can just say at class 10 level, light also behaves in that fashion in certain conditions. Although they are not packaged as such, but they do behave this way, that when this light falls on a metal surface, the entire metal surface is not continuously receiving the light. Okay? There are some portions, tiny portions, which are waiting. And then a particular, this much joule of light, these many joules of light fall there. So we see it in our laboratories that sometimes suddenly an electron pops up out of the metal. That means it has received this light, and this light is pulling it from the metal. If it falls continuously, then no electron will be able to come out. And if the packet is very small, these are experimental facts of photoelectric effect as class 10th level. We say that experiments has been done and is being done in hundreds of laboratories or thousands of laboratories every day. That if those packets are small, say 5 grams of water, they will not receive it. It will come and evaporate. But if it is 20 grams or 50 grams, then yes, then it will burst and then it will water that particular area. In a similar fashion, when light falls on a metal, we see that if light of certain energy is coming, then occasionally an electron comes out, not continuously, occasionally. So light is behaving like packets, grouped in small lumps, having some energy. And if that lump reaches one particular electron, the electron is forced to go out, or you facilitate the electron to go out. These are real experiments. So light can behave like separate particles like packets, and light can also behave like a continuous stream coming. So depending on the situation, both kind of pictures are there, and those packets, those units are called photons. So you can build a story of this type. Yeah, you were saying something.
Sir, my question is, light is an invisible form of energy. We start the chapter like in lower grades. We are not
Bad
supposed to,
start
of course.
anyway.
Yeah,
Go ahead.
I'm talking about the textbook. Textbook starts like
Yeah,
that.
yeah.
And sir, the question is, we say only when an object reflects light, we are able to see the object, and we cannot see light directly. But in space, we can see sun. So, what is reflecting sun's light in space?
Yeah,
That is one question.
Okay.
And second, how are we able to see sun from Earth?
Okay. Right. Very good. Good question. So any question a student asks, the first sentence of the reply is very good question. For all questions, your reply should start with what a good question. Wow. All right. Okay. So first thing is that luminous and non-luminous objects. So you need not use the word. A foreign word distracts. You can say in a normal language, there are something which actually emit light. They don't need some light to fall on them. They themselves emit light. Our bulb is like that. Okay? When it is switched on. When it is not switched on, then it is non-luminous. When it's switched on, it becomes. So there are some sources of light. When you light the fire, so the fire emits light. Bulb emits light. Our LED emits light. A hot object emits light. Okay. And then there are some objects which don't emit light. So when light from an object comes to me, now I am modifying that initial sentence. When a body reflects light, then it is seen. What I am now, I am modifying that. When light from an object reaches our eye, we see the object. If the source itself is emitting light, very good. From the source, light is reaching in my eye, so I am seeing the source. The sun is emitting light, and that light is reaching our eye, so I see the sun. Okay? But then there are some things which do not emit light, and still we see it. So yes, they do not emit light, but someone is emitting light over this poor object. And when that light falls on the object, and from there it comes to our eye, which we say that, okay, the object has reflected the light, then we see the object. So the key sentence is not we see an object when light reflects from it and reaches our eye. Remove that first part. We see an object when light from the object reaches our eye. Over. Okay.
Good afternoon, sir. We are hearing wonderful discussion. So, as a teacher from past 30, 34, 35 years with the experience, and I am looking for one thing from you to any subject with respect to light itself. When we see the student is able to enjoy when he is finally a decisive person. That is, yes, this is right. So, that is where he can enjoy and he can evolve. He can ask something. So from the childhood, so even when they come to degree class, they are in the state of confusion. When they come to class, they are scared. They are scared because confusion lies within them when the confusion is removed. So from your position, what would you say? What is some guidelines at a larger sector to prepare the students in both objective and subjective? See, only objective may not be that fantastic. Element of subjective and the objective both together gives a wonderful, beautiful aspect both for student and the teacher. So, in the background of all questions.
This is a big, very big, please, the big, I don't know, educational research problem. It's a big, it's a nice to do educational research. Okay, but it is a matter of educational research that what kind of strategies schools, colleges must adopt so that without any stress, students enjoy and then correct. So that's a big thing. To me, the vehicle, an object is seen when light from that object enters our eye. So the vehicle is the light there. In our system, any educational system, that vehicle is teacher. Because it is the teacher which interacts with the student. Not the principals also may teach, at that time they are teachers. But administrators do not interact with the students. Policy makers do not interact with the education minister will not. So classroom delivery is by the teachers. So the first thing is, do our teachers enjoy their subject? This is the first necessity. Our teachers should be proud of the subject, whatever subject it is, physics or chemistry or biology or social science. Proud of the subject and keep very happy face all the time. So that people say that, okay, this person doesn't have much of money, but is happier than others. Right? So if that role model is there in front of the students, my teacher is so happy, I should also become teacher. A person who is in education line is so happy, I should also go for the education line. A researcher is so happy, so I should also become researcher. And happiness cannot come by acting happy. You have to be happy. Yeah, you should have to be happy. So first thing, I think whatever is other policies and programs and strategies are made, NEP or whatever it is, the first thing, our teachers should enjoy their subject, all subjects, all kinds of subjects. And even our university system or college system, if the training is not, or in our school system also, the training is not to make them joyful. The training is there to make them stressful. And especially board examination and competitive examination. I am going to in 9th class. Oh God, now I have to study for the board. So middle school it was okay, good. But now it will board. The student is preparing herself that I will have to leave out all my fantastic things that I am doing, okay, because there's a board examination 2 years ahead. It's a huge stressful situation. What nonsense it is. What nonsense it is. A stressful mind can never learn. Your learning can only happen when you are cool, calm, joyful, you are joking, you are meeting friends, you are playing badminton. Then only the learning will take place. And if the learning takes place, if the learning takes place, if you are able to start, if you are able to think, if you enjoy thinking, you know, we in the video we ask so many questions, nice questions, simple questions. But one should read, one should enjoy, one should make. Oh, there's a new thing I learned today. If that joy is there, वो एग्जामिनेशन में नंबर लाने में क्या दिक्कत है भैया? वो तो पीछे पीछे आएगा, वो खुद से आएगा, वो कोई प्रॉब्लम ही नहीं है वो उसको लेके आने में. बट एग्जामिनेशन का एक इधर हॉर्न है, एक इधर हॉर्न है, इधर से ये मार देगा, उधर से वो मार देगा. So, if our teachers are joyful themselves, if they enjoy learning, of course it's an ecosystem. Teachers alone will not be able to do that. It's an ecosystem. Family is there, parents are there, friends are there, other people, management, so many things. It's an ecosystem. But at the end, the delivery is given only by the teachers. The classroom delivery, finally, subject delivery is given only by the teachers. So in that whole ecosystem, student is interacting. The next level after this student level is the teacher. And after that, other things. Okay, so this whole other things will affect. But this is the minimum first requirement. Then our teacher should be made enjoy the subject. Okay, coming out with different kinds of questions, probing questions, prompts. Today, prompt engineering is a very catchy word. Prompt engineering. How to write prompt for an AI bot. Okay, so those kinds. So these are the kinds. So this is the first thing that I can think of.
Hello, sir. I have two questions. One is when we consider silver spoon or steel spoon. So when we have this concave surface, so suppose let's say we have an object beyond 2F or 2F. So how is that we are able to see the image inside the spoon? Because it is forming a real image. But even then we are able to see the image inside that silver spoon.
Acha, so since it was real image, you think that real images cannot be seen, right?
The thing is, they are, getting reflected and they're meeting at a point.
Correct.
But how is that they're forming virtual image?
They're forming real image.
Correct. They're forming a real image. But even then, it is seen behind the spoon.
It's not behind, it's in the front of the spoon. Why do you say that it is behind?
No, meaning I am able to see the image, inverted image in the spoon.
Not in the spoon, in front of the spoon.
But when we consider concave mirror, right? Correct. So whenever we have an object beyond 2F, we are getting it on the screen. And
on the screen?
Yeah, we are getting it on the screen. Okay. So that's a real image. Okay. And we are not able to see that, locate that image in the mirror. But in the silver spoon, we are able to. So how is that possible?
Okay. See, today you did this experiment with convex lens. It's a similar story, concave mirror and convex lens. The only difference is in one case, it is the image on one side, and in the mirror is on the front side, in the lens on the other side. Otherwise, not much different. Real inverted image. So today, without any screen, you could see the real inverted image. And then you had your the object locating pin, and you adjusted the position so that the two are in the same line. You are seeing the inverted image. You are seeing your pin in hand. you are trying to match. So there was no screen anywhere. So in concave mirror also, just like in lens, on the other side there is a converging beam. They meet somewhere, make a real image, real inverted image. If you are standing beyond in the same line, if you are standing at some 30 degrees, you won't see anything. But if you are in the same position, same line, then you see that real image hanging in air at some distance from the lens. Same is the story with the concave mirror also. The concave mirror converges the light, just like this lens was converging, and then it makes a real image here hanging in air. If you are in that same line, then you will see that hanging image. It's not on the surface, it's not behind, it's in front, somewhere here. Okay? And since you are talking of spoon, it's a small thing, and you are always keeping it this way. Okay? So you are in the line. You are in the line. So you can see that hanging image, inverted hanging image. And since the curvature is such that it is close to the mirror, this image is formed not on the surface of the mirror, not inside the mirror, just like plain mirror you have on the other side. You say that it is inside the mirror, but it is not that. But it may look as if it is forming on that concave surface, but it is in front of that. If you keep your eye very close, you don't allow it to converge and you keep your eye there, then you won't see anything. Huh? So next time when you see the spoon, you try to locate with a sharp pin where is your image. Now you know how to locate the image. Okay? You know how to locate the image? If you have an object pin somewhere and lens, then you know how to locate the image to find where the image. The same story, if it is mirror, it will be on this side. There also you can put the pin, the same parallax removing, and you can locate the pin. So you can have a toothpick. You have your image in the moon, in this spoon, and then you can move that toothpick and try to match it with your own inverted image. And you will locate whether it is 1 centimeter from the spoon surface or 2 centimeters or 1.5 centimeters. You can actually locate it. Right?
Okay. The second question is that, sir, we say that rest mass of photon is 0. So does that mean that we have...
Which class? Which standard?
So it is for my understanding.
Okay. Oh, good.
So does that mean, do we have particles of 0 mass?
Yes. Yes, it means that.
Okay.
It means that.
But we were always told that there cannot exist massless particles or massless bodies.
Don't stop telling that.
Okay.
If you have been telling that, now stop telling that.
Even if you consider a small particle such as quarks, so it will have some mass,
yes,
right?
It will. It will.
But this, when it comes to photon, what is it actually made of then?
Oh, what it is made of? Okay, it is your level. I was thinking at which level I have to apply. At your level. It is made of electric field and magnetic field.
Okay.
Light is, whether it is, you call it electromagnetic wave or you call it photon. Light is made of electric field and magnetic field. And that electric field contains energy, magnetic field contains energy, and therefore light contains energy. Light contains energy. Light is not energy, remember. Light is not a form of energy. No. Wrong definition. Light is not energy. Light is not energy. Light is not a form of energy. Light contains energy. Light has energy. Many things have energy. Your glowing bulb has energy. A glowing bulb has larger energy than a switched off bulb. So that also has energy. So energy can be, many different things can have energy. Light also has energy.
There is a statement, heat is a power of energy, sound is a power of energy, light is a power of energy. Now textbook we have.
Light is a form of energy. Now, what is sound? The air particles vibrate. So it is the air particles which are carrying the energy. Sound is not a form of energy. Sound is nothing but vibrations of air particles or whatever medium the sound is going in. It's a vibration of those. When they are vibrating, they are having energy, kinetic energy, half mv square. The sum of all those half mv square will be the energy of sound. So sound is not a form of energy. Sound contains energy. Those vibrating particles contain energy. So light contains energy. Light is not form of energy. This electric field and magnetic field, they have their own characteristics, their own existence. Electric field applies force on a charged particle. Okay, so electric field itself is an entity which exists. It has many more properties. Magnetic field has many more properties. Right? So leave out all those things. It's a form of energy. What form of energy? I was just telling. Is if something I ask, what is this? This is very sweet. What do you infer from that? What it is? It is a rasgulla, or it is a halwa, or it is a payas. What it is? You say it's a form of sweetness. What do I understand from that? What do I understand from that? Many things are sweet. Many things are sweet. What do I understand by that? Similarly, when you say that this is energy or this is a form of energy, you are not telling anything about that object. You are not telling anything about that object. Okay? That object has its own existence, its own interaction with other particles. The magnetic field is deflecting all the cosmic ray particles which are coming from sun and allow us to live here. Otherwise, all those particles would hit the Earth's surface and we won't be able to exist. So the magnetic field has its own existence and its own working patterns. Leaving all those things aside. When you say rasgulla, you don't just say that it is sweet. You say it is made of this thing and then it's put in that syrup, this sugar syrup and this. There's a procedure, the starting material. So you tell all the characteristics of rasgulla. Not that it's a form of sweetness.
Right? Sir, what would be the source of these magnetic field and electric field inside this photon?
The source is, first it was emitted from some source. So it starts from there. But once it gets emitted, then source is not needed. This electric field and magnetic field, which is there in the light, they are oscillating, they are changing in time. They are like sin omega t variety. I am answering at your level.
Yes, yes.
Okay, so the electric field and magnetic field both are oscillating. And of many characteristics of electric field, one is if the electric field changes in time, if the electric field magnitude or direction, if it is changing in time, it will create magnetic field. And of the many characteristics of magnetic field, there is one that if the magnetic field at a place changes with time, then it will create electric field. So once the light is emitted by the source, when it is emitting, yes, that source is providing that energy, that electric field, that magnetic field. But once it is detached from the source, it is self-sustained model. The electric field which is changing is creating the magnetic field. The magnetic field which is creating the electric field. So they are interchanging, this is creating that, that is creating this. It has become a self-sustained entity and that travels as light. Okay? That travels as light.
Sir,
Yeah.
In one of the case of a concave mirror image formation, so when you keep the object at focus, We used to study that image will form at infinity, but some are saying no, the image does not form only. What is the case?
So the lesson is what NCERT is writing. When you use ChatGPT, all the time there is a disclaimer, ChatGPT may be wrong. You see every time this message. In a similar spirit, when NCERT says something, there is a disclaimer, NCERT may be wrong. And they have self-corrected it. ChatGPT also does that. They make mistake, but if I insist, recently I was doing something, and then it was giving, and I was saying, no, this is not possible, it's unphysical and this and that. You have drawn the wrong diagram, etc. And it was trying to defend itself. But ultimately it gave up. And it said, then it writes, thank you for insisting we were doing wrongly. But before that, it was trying to defend itself. But at the end of it, it said, okay, leave it out, let us go some other way. So some other way, they got the right result. And then at the end, it thanked me. Thank you for insisting, not believing me. Okay. But then ChatGPT has corrected itself. Now the same question, if now someone asks, it will give me the correct answer. So NCERT had corrected itself. So far it was wrong that image formed at infinity. Now they say that image does not form.
Image does not form, yes.
Okay, so this is a better version. But my question is, can you put an object at the focus? Can you put an object at focus? Your focus is a point, right? Your focus is a point, having no spread, no dimension, no spread, no size. Your focus is of zero size. Focus is a point where all the rays are converging. All the parallel rays, after that, they are converging at a point. You say that, they converge at a point. And if they converge at a point and that is focus, can you have an object of point size? Can you have an object? This is the question that should come to the mind. This is the question that should come to the mind. I have just now studied a paragraph above that focus is a point where all the parallel rays converge after reflection. And in the next page it's saying that put an object at the focus. So I should be able to see that. There's an anomaly. There's an anomaly right here. Right here. Now you can say that the other thing is okay, fine, good, very good. But we are not mathematicians. We are not mathematicians. Okay, it's a spread, fine, doesn't matter. My ray also had a spread. And all that. So you can go for a modeling, mathematical modeling. Okay, we do have a point size object. For me, point size, my point is slightly spread, doesn't matter. And then what will happen? So those kind of things can be done. But NCERT, why NCERT is writing that it does not form is that after reflection they are still parallel. Say they do not meet and do not appear to meet when produced behind. So now they are saying that the image does not form. That my question is, who will go with the object to put at infinity?
Sometimes that infinity point may
Oh,
be
sun is at
all of
15 crores kilometers. It's not infinity. It's not infinity. Sun is at 15 crore kilometers. So infinity is not a place. Infinity is not a point. Infinity is not a number. Okay? Shastri, infinity is not a number. Whenever you have a number, you can always add 1 to it and you will get a greater number. And infinity is something which is the greatest. Nothing is greater than infinity. If infinity is a number, I can always add 1, 2, 3, 4, 10, 20 and get a number greater. So this infinity is gone. That has become infinity. And then I will add another 20 to that. So this is also gone. So infinity is not a number. It is not behaving as a number. You do not add 2 to infinity and you say that the value is larger. You cannot subtract 2 from infinity and you say that the value is smaller. It is not following the law of land. So it cannot be given citizenship of being a number. No, it's not following our constitution. Bangladeshi hatao isko. Okay? So infinity is not a number, infinity is not a place, infinity is not a point. But you are very right. The kind of measurement equipments we have, the kind of things which matter for me, okay, whether it is at 10 kilometers or 100 meters or 50 meters, I get the image at the same position. Same position means I have my own measuring apparatus. I do not measure in angstroms. I do not measure in nanometers. I measure in millimeters, or at best 1/10 of a millimeter. So for me, if something is changing by 100 of a millimeter, 10 micron, I have no way to distinguish. I have no way to distinguish whether it formed here or 10 micrometer ahead or that. So for me, that is a point. So 10 meters forming here, 20 forming here, 30 forming here. So for me, the 10 is also infinity, the 20 is also infinity, everything is infinity. So depending on my own situations, own operators that we have, we say that, oh, ठीक है, कितना भी दूर रहे, क्या फर्क पड़ता है, so call it infinity. So in that sense, we are treating the word infinity. But if you go by mathematical precision, no, there's nothing like that. But when you are insisting that I have put the object at focus, where will the image form? You are going for that mathematical precision. Now it matters. Now it matters. Okay? NCERT has not addressed this issue. They have addressed the issue that reflected rays are parallel, and therefore no image forms. They do not meet or do not appear to diverge from something which is behind. So they say that, but my question will be, when I put the object, part of my object will be inside between F and that pole P, and part of my object will be on the other side. So part of it will form a virtual image and part of it will form a real image. Okay? So that is the question to be addressed, main addressed. NCERT has not addressed this question even in the newer textbook. So that disclaimer still remains there. NCERT may be wrong. Rainbow. Rainbow is an, I'm repeating because everyone should hear. So rainbow is rectangles and two triangles, that we call prism. And our droplet is like a sphere. Okay. So the idea is that which property is there. If I say that prism also says the speed of light is 2 into 10 power 8 in prism, and the mirror or any slab also it is 2. So in that way they are similar. They are of the same refractive index. So they are similar in one category, in one group. Okay. So in that sense, if it is the context of the refractive index, yes, the prism behaves like a lens behaves like a prism or a slab. It is fine, no problem. But you should not think that everything will be identical. Why then two different names? So your droplet also splits the light in different colors. Your prism also splits the light in different colors. Prism you are familiar with. Already you first study prism. I hope so. I do not know. I believe so, or I guess so. You are familiar with the prism that it disperses light in different colors, and then you say that the droplets are also doing that. So you say that it is like prism. It's like prism. So it is a very there are many differences. So one difference is this: in the prism there is no internal reflection involved, but in the droplet, yes. But okay, well, the final point was that okay, this also splits the light, and there's also split the light. So you can say that this behaves like that. See, our object is never a point object, it is an extended object. And for teaching purposes, we always take our object a linear, line-like image, line-like object, right? You make a line AB. Right? So if your object is on the principal axis, and normally when I say this AB, one point A is on the principal axis. And then it will create image on the principal axis. Okay? And for the other one, the image is still formed. But at the same position then going down in it. Alright? So going down, that's the important part. Now suppose you are receiving light from a faraway object and it is coming parallel to the principal axis, getting reflected and converging at the focus. If your object, faraway object, is not on the principal axis, above, then it will form below the focus. And if the size is smaller, bigger, then it will be, the distance will be here, 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 it will form here. If the object is moved left, right, then the image will be also left, right. But this whole thing, this whole possible position of the image, when your object is above the principal axis, below the principal axis, to the left of the principal axis, to the right of the principal axis, 45 degrees from the principal axis, all that will be formed here, 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 here. That is a plane. And that plane passes through the focus. Okay? So that is the focal plane.
Sir, I have a question. Sir, today I would like to learn this. We did a wonderful experiment demonstration where you showed us that as the angle of incidence was increased, the intensity of the reflected ray, partially reflected ray, it was increasing, right? And I was thinking that what if this was conducted as the ray was traveling from denser to rarer medium? If the ray was traveling from denser to rarer medium, as we increase the angle of incidence, there will be a partially refracted ray that will bend away from the normal, right? And up to critical angle of incidence, beyond which the entire ray will be reflected back. So, but even then, even beyond the critical angle of incidence, even after the total internal reflection, will there be a partially reflected ray? If yes, then how will its intensity increase beyond?
Okay. So there are several disconnected parts. I can see your question. So if I go only for the last part of it, even after the total internal reflection is achieved and the angle of incidence is more than critical angle, your question is there a refracted ray?
And what about its intensity?
First, is there a refracted ray? Now the answer to it is somewhat difficult. And you are asking for yourself or for your students? Not necessarily. You know many things that you should not share with the students, okay? You may be knowing your principal's salary. Never share it with your students. Your principal will kick you out. Say its answer is not easy at class 12 level, right? So, but the fact remains is, it is not refraction, it's not refracted ray, but some electric magnetic field do enter in that second medium, but it doesn't propagate. The light is an electric field and magnetic field combination. So when I say that the light has gone to the surface and total internal reflection has taken place, that gives me the impression that whatever electric field, magnetic field that ray was containing, that everything is reflected. And it is, yes, it is true, and no, it is false. Both the answers are there. Because above the surface, on the other side, where we say that, okay, everything has been reflected, other side, you do find or you do have some electric and magnetic field penetrating in that region to a small length of the order of a wavelength. One wavelength, two wavelengths, like. You do have. That electric magnetic field is there. And somehow if you can bring another glass, suppose it is glass to air, okay, and in the air there's a gap, and then you have another glass here, and if the separation between them is of the order of wavelength, then this electricity magnetism which is there can enter in that second glass, and then it will become a ray. Then it will go ahead with just like a ray. So it does penetrate the second medium. But if you don't bring that glass, that penetration is only up to a thickness of the order of one wavelength. And that is not a ray. It's not traveling in this direction or that direction or that direction. It's just a combination of electromagnetic wave, which is electricity and electric field and magnetic field, which stays there. So that happens. Now there are much bigger theories to explain this phenomena, but that's the kind of, you do not call it a refraction, there's nothing like Snell's law, etc. But yes, some electric magnetic field does appear on the other side. And it is fixed. Not that it is going up, growing up, and no more and more electric magnetic field is coming out, no. That light is coming and reflecting, but whatever is small layer is formed, it is steady. New light is coming, that's still going that way, as if it's not adding to that that part, that other part. Right? We have to conclude. You have my mail address. You have we can write it again. You can have my mail address, and you can write your questions, and I'll try to reply. All right? Thank you.
Thank you very much, sir. It was an amazing session, the whole day session that we had with you, and you gave us time. And it's also fantastic to see that everybody, the teachers have come prepared with the very relevant questions that came forward, because ultimately it's always, both-sided. That communication is the key. The learning that happens is through both ways communication, and we could see that the kind of questions that were being poured out today, that itself sort of indicate that yes, this we really are taking quite a meaningful message out of it. And as sir said, that it's so important that we connect with the examples which are there, and child himself or herself, they have that inquisitiveness. And the most important lesson is that we need to actually accept that their learning is far more superior at times, and we need to really go in that flow and try to relate ourselves, and in the process we learn better science or understanding of the nature. So with this, how much do we express? It's less only, sir, but we would convey our hearty regards, and I request everybody to give a big round of applause for sir. on this occasion, we all, and I would also like to mention here, because this is National Science Week programs, each one of your teachers also must be busy during this time. You all have taken out the time to understand the relevance of this subject today, came here to attend this, and I'm sure that tomorrow when you go to the school, you will have better explanations of many phenomena, and you will be able to communicate in much more clearer way to the students, and that is the whole intent of this workshop is that. So thank you very much to all the teachers that have put an effort to come for this program. And while I say so, I would also like to tell that we do not want to conduct just like a once in a while program. Now today when we have this session, all of you will be becoming a part of a group. We will create a WhatsApp group, a community. So this is how we all exchange our knowledge. If there are doubts, we share over there, and then we all write to sir that once again we will have him sometime. Let's have when next we will plan it out accordingly. And now we are a bigger force that will push it forward. So I hope it won't take this much time next time. So thank you very much to everyone once again. All my colleagues who are here that really have put in a lot of effort to make a very smooth coordination of this program. And Amit sir, you are, the force, like you really led it all with, as a, the execution was seamless. Thank you very much for your presence. And I just wanted that, I requested, sir, that you please share another number also, because it was so, it was not easy to every time talk to sir because he is so busy. So that's how Amit sir really made everything so easy for us to coordinate here. There was no gap as such. We had a complete clarity on how the program has totally overall executed. So once again, I convey my hearty thanks to everyone. And we have certificates also kept ready. I do understand that beyond the certificate, there is much more we are taking away today. But even then, as the program norm goes, we will be sharing these certificates to your respective schools, and we'll be sharing the details as we are in the WhatsApp, going to be in the WhatsApp community. We'll coordinate with you on that. So thank you very much once again, and stay motivated and keep visiting the museum, because this is a space where you get to see the hands-on science in action. So thank you. Thank you, everyone.